Uniform circular motion describes movement where an object is moving on the periphery of a circle at a constant speed. And so the tip of the hand of a clock would describe uniform circular motion. The generality is that one says that um, there's a radius r about some center. That's the dot that I have right here. And we will say that the period t is the time for the object to go around the circle once and come back to its starting position. So t is the time to go around once. R is the radius. Omega, this is a Greek letter now. Looks like a W, but it has the top of the W is kind of curled in a little bit. Is the um, angular speed, angular frequency. And that is going to be 2 pi rads, because 2 pi radians represents an angle once around, divided by t in seconds. And so these are the units we're most frequently going to use, radians for angles and seconds for period. There are some alternate ways of expressing angular frequency, however. Angular velocity, angular frequency. And the several ways comes about, for example, because 2 pi radians is equivalent to 360 degrees, which is equivalent to 1 rev, rev being short for revolution. And so one of the units for angular velocity or angular frequency is RPM, revolutions per minute. And so if you wanted to convert RPMs to rads per second, you could simply write out 1 rev per minute, and then multiply by a 2 pi rads per rev conversion factor, which converts revs to rads, and then multiply by minutes divided by seconds, which will convert minutes in the denominator to seconds. And so that is going to be 2 pi over 60, which is pi over 30 rads per second, and that's roughly equal to a tenth of a rad per second.